Hi, and welcome to week 2 of our 30-week countdown from TheMathsTutor.ie. So this is the Leaving Cert Ordinary Level Countdown. And this week we're going to be looking at linear algebra. So when we're looking at linear algebra, there's a couple of things that we need to know about. So a couple of words that we're going to see repeated over and over again that are going to be good to kind of get our heads around. So the first thing is when we're talking about algebra, we're going to see X's and Y's and A's and B's and lots of letters coming into play. And when we see these together, when we have lots of these together, we often call these expressions. So when we have something like simplify this expression or evaluate this expression, this is when we have X's and Y's together. Sometimes then we're going to see equations. So when I see the word equation, this means that we have to have an equals in it. So it's just to be aware of those two different words, that if I see an expression, there won't be an equals in it. And if I see equation, there'll have to be an equals in it. And while we're looking at a couple of these words, so not only do we have terms like expression and equations, we have another couple of words that are going to be really important as well. And these are kind of like, what are they asking me to do in this question? So sometimes they'll ask me to evaluate. So if I'm asked to evaluate an expression, that means find the value of. So evaluate, find the value of. This is where I'm going to be putting in values of X's and Y's, and I'm going to be seeing things like this in a question, and I'm going to be subbing in and finding a value. If I see something like simplify, so if it asks me to simplify expressions, if something is being simplified, that means it's going to be made easier. So if I'm simplifying something, I'm making it look easier, and that means it's going to be still X's and Y's, but it's just going to look a little bit nicer or a little bit easier for me to deal with. Okay. If I see solving, so this is one that often comes up, solving linear equations. So when I want to solve, this is where I'm going to have to figure out what that letter stands for. So we said algebra is going to have all these letters in there, X's and Y's and A's and B's. And if I'm asked to solve, it means my last line is going to say X equals, or Y equals, or A equals, whatever number, whatever letter was in the question, and I'm going to work out what number that letter stands for in this sum. So that's just to kind of give us an idea of some of the words that we're going to see as we look at a couple of questions. And then we'll see not only will we be asked to evaluate expressions and simplify expressions and solve linear equations, they're going to ask us a couple of other things here in this linear algebra as well. So some of the other things that they can ask us are simultaneous linear equations. So simultaneous equations mean that we have two equations at the same time. So simultaneously, and we're going to have X's and Y's in both of them, or A's and B's in both of them, or whatever letters will be popping up in both of them. And we're going to have to solve those. Because they're equations, they're going to have equals in them. When we talk about linear, so we're saying linear equations and linear algebra and simultaneous linear equations, that means that these form a line. But how I know that by looking at them is that they're going to have two letters. So usually we'll talk about X's and Y's, and they don't have any squares or cubes or anything like that when we look at them. So we'll just have an X and a Y, no powers of 2, no powers of 3, and that's going to make it linear. One thing we will look at as an example of is a linear inequality. So when I have an inequality, these are the things that you might remember having come across before, where you're going to have less than and greater than, or less than and equal to, or greater than or equal to. So when we're dealing with an inequality, there's just one extra step that we have to remember on top of our linear equations. Some other things that they might ask, and these are the two videos that we've just popped into the comment section for you there that you might want to go and look at after the lesson. Linear equations with algebraic fractions. So when we're talking about linear equations with algebraic fractions, this is where we're going to have to solve an equation. So we normally have X's in them. Our last line is going to be X equals. And when we want to solve for X, but it's going to be in a fraction to start with. So this video is going to talk you through how to deal with having X's in your fraction. And the other video is plotting linear functions. So functions and link together an awful lot with our algebra. And we're going to see that plotting a linear function is going to show us how do we draw a line. So plotting a linear function, that video is going to go through how to draw a line with you. So those two videos are in the comment section for you there to go and follow up on. Today then we're going to go and look at a couple of questions from the papers, and the first one we're going to start with here is 2021. Linear algebra often comes up on paper 1, but we are going to see that we can also come across it in paper 2 in different places, not normally as a standalone question. So here in paper 1 we'll see a lot of standalone questions. So this is question 4 from 2021 paper 1, and it says solve the equation. So there's two things that I'm spotting there when I look at that. It says equation. Oh, sorry, not on the highlighter. So it says equation, and the reason it says equation is because there's an equals. And the other thing that I'm going to spot is that it says solve. So I'm seeing that it's asking me to solve. So the variable or the unknown in this equation is an x. So I see we have an x here and we have an x here and we only have one x. And because it's asking me to solve this equation, I know that the last line of this answer is going to say x equals a number. So if I'm asked to solve an equation, that's what I'm going to work towards. So what I need to do with this is I need to remember how I deal with algebra. So when I have algebra, if I have a number or a letter in front of a bracket, it means to multiply everything that's inside that bracket by what's touching the bracket. So here we have a 4 touching this bracket. So I'm going to say 4 gets multiplied by the 2x and 4 gets multiplied by the plus 3. The minus 7 over here, so we have a minus 7 after that, that's not touching the bracket. That's saying the 4 is touching the bracket, that's your multiply, and then we're going to take away 7 from that answer. So that doesn't get multiplied by the 4, only the things that are inside the bracket. So when I start multiplying, I get 8x plus 12. So 4 times 2x is 8x, 4 times plus 3 is plus 12, and then the minus 7 stays as it is. So that wasn't being multiplied. Next, I have my equals, so I put down my equals, and on the other side of my equation, I see that I have a bracket with the 3 touching it. So the 3 is going to be multiplied by both things that are inside this bracket, and I get 3x minus 15. So that's the first step that we have to deal with here, is multiplying out those brackets. Once I get to this stage, I now want to have x equal to a number. So that means I want all my x's together on one side of this equation and all of my numbers together on the other side of the equation. And what's really important with equations is I'm allowed to do anything I want to one side of the equation as long as I do exactly the same thing to the other. So once I do, if I add a number on one side, I have to add it on the other side. If I multiply on one side, I have to multiply on the other. So what we're going to do is, well, first of all, I'm going to see like goes with like. So I can tidy up this side a little bit and I'll say 8x plus 12 minus 7. They go together, and on my calculator, that's going to give me a plus 5. Is equal to, and I can't put these together because, as we say, like goes with like, and that's the phrase that we use in maths a lot. And what that means is that I can only add x's to other x terms. When I have a minus 15 on its own, we call that a constant. It doesn't have an unknown in there. So now I have 8x plus 5 on one side of my equals and 3x minus 15 on the other side. I'm going to do two things to both sides of this equation. So the first thing I'm going to do is I want x's over here, which means I don't want this plus 5. So I'm going to say I'm going to get rid of that plus 5. Now, the way that I'm going to do it is I'm going to say let's take away 5 on this side. And if I take away 5 on this side of the equation, so we had plus 5 and I'm going to say let's take that away. And as long as I do exactly the same thing on the other side of the equation, that's perfectly fine. On this side, the adding 5 and the taking away 5 leaves me with just 8x. And on the other side, again, we go like with like. So the 3x stays on its own, and minus 15 minus 5 gives me minus 20. So we're getting closer to what we want our answer to look like, x equal to a number. So I now have 8x is equal to 3x minus 20. So the next problem is this 3x over on the right-hand side. So I'm going to get rid of that from both sides. So we're going to say take away that 3x from both sides to get rid of it over here. So we don't want a 3x over here. And now we have on the left-hand side 8x minus 3x, and like goes with like, that gives me 5x. And I'm left with minus 20 on its own over here. don't forget that there's a minus in front of that 20. So sometimes people drop those minuses. They just prefer positive numbers and it just disappears. So just keep an eye that there was a minus in front of the 20, so we have to hold on to it. And then again, I'm going to do the exact same thing to both sides. So when I have a 5 touching an x, when things are touching, it means multiply. So the same way that when we multiplied the 4 by the 2x, we got 8x and they were touching, we're doing the same thing here. So this is 5 multiplied by x, and we do the opposite on both sides. So we're going to divide by 5. And that leaves me with x on its own on this side, which is perfect because that's what we want, x equals. And on our calculator on the other side, we get x is equal to minus 4. And now I have solved this equation because I now have finished up with x equal to a number. And it says here in the terms and conditions, so just in the question again, where x is a real number, and that means that I could have absolutely any answer except for my complex numbers. So x equal to minus 4 is perfectly valid. So that's the first example we're looking at solving an equation. The second example we're looking at here, this is from 2015. And again, it's paper 1, and this time it's question 3. And there's 2 parts that we're going to look at here. So again, I'm looking at what are they asking me to do in this question. So this question is saying simplify. So I'm not solving for x here. I'm not going to work out what x is. All I'm going to do is tidy this up and make it look a little bit better. We have a number touching the bracket again, so this is going to be our multiply. So 3 multiplied by 4 is 12. 3 multiplied by minus 5x is minus 15x. Minus 2 multiplied by 5 is minus 10. And minus 2 multiplied by minus 6x is plus 12x. So when we multiply out those brackets, we get our 12 minus 15x minus 10 plus 12x. To simplify this further, all that's left is to put like with like. So again, the x's can go together. So my x terms, minus 15x plus 12x, they're like terms, so we put those together. If you're finding those a little bit difficult, you can do them on your calculator just without the x. So you can just say minus 15 plus 12 on your calculator, and that gives me an answer of minus 3. And then I just have to remember to put in what was the variable in this question. So it was minus 3x. And 12 minus 10, they're constants. They don't have any variable, so they've no letters attached to them. So again, I'll just pop those into my calculator and say 12 minus 10 gives me plus 2. So when I simplify these brackets, I get the answer of minus 3x plus 2. And that looks much simpler than 3 bracket 4 minus 5x bracket minus 2 bracket 5 minus 6x bracket. So I've done what they've asked me to do. I've simplified it. It also doesn't matter what order you do them in. So if you wanted to do the 12 minus 10 first and you got 2, and then said minus 15x plus 12x and got minus 3x, both of those answers are exactly the same. So what's important is that the sign stays with each of the terms. So the 3x has a minus and the 2 has a plus, and we keep them together. Okay. So that was simplifying. Whereas part B, there's kind of a couple of parts to this question. So the first thing I'm spotting is this word inequality. And when I spot this word inequality, I'm seeing I don't have an equals, I have one of my inequality signs. So the sign that we have here is greater than or equal to. And sometimes people get a little bit confused about which one is bigger and which one is smaller. So I kind of say it looks a bit like an arrow, and the arrow always points to the small side. So I'm saying the minus 6 is the small side, so the 2 minus 3x is the big side. When we want to solve an inequality, we start off exactly the same way as we do with an equation. And what I mean by that is we want to get x on its own and a number on the other side. When I want to do that, I'm allowed to do anything I want to one side of the inequality as long as I do exactly the same thing to the other side of the inequality. So that's exactly the same as with my equations. As long as I do it on the left-hand side and the right-hand side at the same time, then it's perfectly allowed. There's just one exception to this rule. And the exception to this rule is with an inequality, if we multiply or divide by a minus, the inequality points the other way. So the sign points the other way. Okay, so that's the rule that we just need to bear in mind with our inequalities. So if I multiply or I divide by a minus, then the inequality sign is going to point in the other direction. Okay, so we'll see if that applies here. So we have 2 minus 3x is greater than or equal to minus 6. I want x on its own. So this was like we were saying with our inequality and how we were solving our inequality. We're going to do the same thing to both sides. So I'm going to subtract 2 from both sides of this inequality. And that's absolutely fine. I'm subtracting 2, so I'm not multiplying or dividing. And that means I haven't to take this new rule into account. So I'm going to say 2 and minus 2, that leaves me with minus 3x on the left-hand side is greater than or equal to, and into my calculator, minus 6 minus 2 gives me minus 8. Now I'm going to say I want to get this x on its own. So that means I'm going to divide by the number that's attached to that x. So that number that's touching that x, we've said, means it's being multiplied by it, and we're going to have to divide both sides by it. But what I'm spotting is now I'm dividing by a minus number. And that means that we're going to have to look at this rule. If I divide by a minus number, the inequality sign is going to point the other way. So that's the first thing I'm going to write down. So it was a greater than or equal to, and now I'm going to point it the other way around, and it becomes a less than or equal to. On this side, my minus 3's will cross out and I'm left with an x. And on this side, when I pop that into the calculator, I get 8 over 3. So it changes to a positive number, 8 over 3. I've now solved my inequality. So my inequality is that x is less than or equal to 8 over 3. And that's how I go about solving my inequality. But I have to make sure that I'm answering the question that they've asked me in each question. So every time I get a question, I say, I know how to do this sum, but have I answered exactly what they've asked me? So it says, list all the values of x that satisfy this inequality. So I actually need to write down, well, what are the numbers? And it tells me that x is an element of n. So this is what we were looking at in week 1 with our natural numbers. And we said our natural numbers are our counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8. We can't have numbers like 8 over 3. That's a fraction, that's a rational number, but it's not a natural number. So I'm going to stick this into my calculator and just to get an idea of, well, what number is 8 over 3? So when I put that into my calculator, I get 2.6 recurring. Just so that I have an idea of what number is 8 over 3. So here it's 2.6 recurring, and it's saying list the natural numbers that are smaller than 2.6 recurring. So recurring, remember, and that's that little dot that's on top of the 6, just means that it goes 2.666666666, and that 6 keeps going forevermore. So we could keep saying number 6 for the rest of the time. It's a recurring decimal. So this question is saying list all the natural numbers that are less than 2.6 recurring. So there's only 2 of them. So x is equal to 1 or 2. And that's it. So the important part with that question is to make sure we're happy with solving the inequality, that we're doing the same thing to both sides, and we bear in mind this one extra rule. And that one extra rule is that if we multiply or divide by a minus, then we have to change that inequality and make sure that it points in the other direction. The next thing that we're going to look at then is our simultaneous equations. So this is 2018 paper 1 question 3, and this is asking us to solve the simultaneous equations below to find the value of A and the value of B. So again, I'm saying, well, what is the question asking me to do? So it's asking me to solve. So when I'm being asked to solve, I know that I want to say A equals. And I also want to say B equals. So when I have a simultaneous equation, I have to be able to solve for both of the letters that are in it. So in this case, we're going to see we have 2 equations, one with 2a plus 3b is equal to 15, and the other with 5a plus b is equal to minus 8. There's a couple of ways to solve simultaneous equations. I tend to stick to the same method each time so that I don't make mistakes trying to figure out what am I going to do with it. So I always say, let's look at the second letter. So the second letter in each of my equations is a b. And when I look at the b, I want the number of b's in each equation to be the same. So I've got 3 b's in the top line and I've only got 1 b in the bottom line. So that tells me I'm going to have to change something to make them the same. And the second thing that I look at is I look at the sign that's in front of those letters. I want one of them to be a plus and one of them to be a minus. So at the moment, they're both pluses. That means that I'm going to have to multiply one of my equations, or maybe both of my equations, to get the same thing in front of the b's, but with different signs. So at the moment, I have 3b on the top line and b on the bottom line. So if I multiply the bottom line by 3, I can see that this b here will change to a 3b. That's great, but then I have plus 3b and plus 3b. And how we solve simultaneous equations is we add together everything that's on the left-hand side of the equations, and we add together everything that's on the right-hand side of the equations. But if I add these together, the b's don't cross out or eliminate. So this is solving by elimination. So I have to be able to get rid of those b's. So what that means is I'm going to say, well, I need one of them to be a plus and one of them to be a minus. And since I'm already multiplying the bottom line, I'm going to multiply by minus 3 rather than multiplying by 3. Sometimes we'll see different numbers, so we might have to do the lowest common multiple of the two numbers. The easiest thing to do is say the bottom line gets multiplied by the number in front of the top line letter, and the top line gets multiplied by the number in front of the bottom line letter. Here there's only a 1b on the bottom line, and multiplying by 1 means I'm not changing anything, so I don't have to multiply the top line. So I'm going to say 2a plus 3b is equal to 15. That's my top line. And everything in my bottom line gets multiplied by minus 3. So I say the 5a gets multiplied by minus 3, and I get minus 15a. The plus b gets multiplied by minus 3, and I get minus 3b. And on the other side of the equals, the minus 8 gets multiplied by minus 3, and I get 24. So now when I look at these equations, I see that the number in front of the b on the top line is a 3, and the number in front of the b on the bottom line is a 3, and one of them has a plus and one of them has a minus. So now I'm going to say, let's add these two lines together. So on the left-hand side, my a terms go together. So I say 2a plus minus 15a, and like we said earlier, we can put that into the calculator without the a's, and I can say 2 minus 15 is minus 13, and then just put the a back in. Plus 3b plus minus 3b, they cross out. And on the other side of the equals, we say 15 plus 24, and that gives me 39. And now I've taken my two equations which have a's and b's in them, and I've turned them into one equation which only has one letter in it. So now I'm going to be able to solve for my first letter. So I'm going to be able to solve for a. So when I solve for a, I'm going to divide both sides by minus 13. So remember, I can do anything I want to one side of the equals as long as I'm doing exactly the same thing to the other, and just keep an eye on those minuses. So in this case, my minus 13s cross out and I'm left with a. And on the other side, into my calculator, 39 divided by minus 13, and I get a is equal to minus 3. So I have solved this equation for a. So it told me to solve to find the value of a, but now I have to go back and find the value of b. So when I want to go back and find the value of b, we use substitution for this. So what this means is that I take either of my equations. So it doesn't matter which equation I take one of my equations and I'm going to use substitution. So substitution means instead of this a here after the 2, I'm going to put in the minus 3 instead. So it's a substitution. We take out the a and we put in minus 3. So we say 2 times minus 3 plus 3b is equal to 15. And these are multiplies, so we get minus 6 plus 3b is equal to 15. And now we have an equation that's just in one letter, b, and we're going to do the same thing to both sides of that equation. So I'm going to add 6 to both sides. and I get 3b is equal to 21, and I divide both sides of that equation by 3, and I get b is equal to 7. So I've solved my simultaneous equation and I got my answers for A and B. If you wanted to check your answer, you could substitute into the second equation. So we could say 5 times minus 3 plus 7, and our answer would be minus 8. And that allows me to check that I've actually done this question right. That's some of the linear algebra that comes up on its own in paper 1. But we mentioned that sometimes we'll see it in paper 2 as well. So the last question that we're going to see here is from 2021 again. And this time it's from paper 2, and it's question 3b part 2, which says find the point of intersection of these two lines. So this is actually from coordinate geometry of the line, but I can see that it's giving me two equations. 3x minus 4y is equal to 5, and 2x minus y is equal to 10. So I have two equations in two unknowns, x and y. So I'm going to solve this using simultaneous equations again. I have a 4 in front of the y on the top line and a 1 in front of the y on the bottom line. So I'm going to have to multiply by 4. And I have two minuses this time. So again, I need one to be a plus and one to be a minus. So I'm going to multiply by a minus on the bottom. So the top line stays as it is. 3x minus 4y is equal to 5. And the bottom line, everything gets multiplied by minus 4. So 2x by minus 4 is minus 8x. Minus 4 by minus y is plus 4y. And minus 4 by 10 is minus 40. And I check that these two equations, we have the same number in front of the second letter. So we have 4 in front of both of our y's, and one of them has a plus and one of them has a minus, and we add them together. So we say 3x minus 8x is minus 5x. My y's cross out, and 5 minus 40 gives me minus 35. And we're going to divide both sides by minus 5 to get x on its own, and we say x is equal to 7. And once we solve simultaneous equations, once I get one of my letters, I have to substitute in to get the other one. So I go back, and it doesn't matter which of the equations I go back to. So I tend to go back to the top one, which says 3x minus 4y is equal to 5. So 3 times 7 minus 4y is equal to 5. So that's 21 minus 4y is equal to 5. And again, as long as I'm doing the same thing to both sides of the equals, so I'm going to subtract 21 from both sides. Minus 4y is equal to minus 16. And we divide both sides by minus 4. And when we divide both sides by minus 4, I get y is equal to 4. So I've solved the simultaneous equations between these two lines. The only thing that I have to answer here is that it says find the point of intersection. So this is a little bit different. So it's from paper 2. So it's a little bit different to the algebra we were looking at a minute ago. I now need to put these together as a coordinate. So we're going to say 7, 4. Okay. And if we have enough time, we'd go back and check our answer by subbing into both of those equations and making sure that we have the right answer so that we'd be able to say, I'm definitely happy with this question and I know that I've gotten both of these answers right. So that's how we're going to look at our simultaneous equations and how we solve those. So that's our linear functions and our linear algebra, just to give you a little bit of an idea of some of those things. And as we said at the beginning, there's 2 videos gone into the comments. One of them is going to be on your fractions, so your algebraic fractions, and the other one is on plotting your linear functions. So you can go and have a look at those, and hopefully that's been of some help to you. And we'll see you next week for week 3 of our 30-week countdown to the Leaving Cert Ordinary Level Maths. And the countdown is available for your full members on the TheMathsTutor.ie website. Thanks.